Okay, question 1, we've got a dice rolling problem. The number variable x represents the number of times the die lands on a 6. Use a suitable distribution model for x to find where specifically x equals 3 and where x is less than 3. Well, the model is going to be a binomial model because this either lands on a 6 or doesn't land on a 6. So it's a yes-no, win-lose situation. So setting that up first with all the parameters. And there we have the binomial distribution. We've got 10 trials and the probability of success in those trials is 1 over 6. So using a calculator, if we substitute x is equal to 3 on the calculator, pop in n is equal to 10 and the probability is a sixth. And we get that this probability is 0.15504 and on it goes. Or 0.155 and that is to 3dp. And this, of course, was using the binomial probability distribution on the calculator. And for part 2, because we need an area, we need the cumulative distribution. Now, for the probability of x being less than 3, that means it can't be 3. And because the calculator can only calculate up to a limit has got to be 2. So this becomes the probability of x being less than or equal to 2. So 2 is the number we're going to have to type in. That, with 10 and a sixth probability, will give an answer of 0.775, and that is to 3dp. And that's the answer to part 2. So in part B, this experiment of finding where x is equal to 3 is repeated 60 times. And we're supposed to find the probability where at least 12 days where you find that x is equal to 3. Well, again, this is going to be a binomial distribution. N, or the number of trials, is now 60, and the probability of x is equal to 3 is our answer here of 0.155. So let's set this up. And here is the new distribution. 60 trials, a probability of 0.155. Again, the distribution is a binomial distribution, and we've got to find the probability that there were at least 12 days. So what does at least 12 days mean? So this is the condition of acceptability. Now, the calculator only calculates up to and including. So what we've got to do is we've got to pop in 11 as our limit, counting upwards from 0, and then subtract this probability from 1 to get the answers that we want, the red ticks here. So first of all, we need the probability of x being less than or equal to 11 up to this limit. And if you put the values into a calculator, and that is the probability of 0.155, the number of trials 60, and x up to and equaling 11 in the binomial cumulative distribution function, you get the probability is 0.788. So therefore, the probability of x being greater than or equal to 12 is 1 minus 0.788, which is 0.212. And that's the answer to part B. In part C, we've been asked to find an estimate for the total number of sixes that's in rolls in these 60 days. Well, how many throws is he going to be doing? Well, it's going to be 60 days, 10 times, so we've got a total of 600 throws, and the probability of getting a 6 is 1 over 6. So this very simply works out to be 100. And that's your answer to part C. In part D, we've been asked to use the normal approximation to estimate the probability that Zian rolls a total of more than 95 sixes in these 60 days. Well, let's write down the normal approximation first. And here it is. Here it is expressed in binomial variables, and here it is expressed normally. Now, in part C, we've effectively worked out the mean. This is the mean, mu is the mean, and this is the number of sixes he should get, this being n and this being p. So we know np already. All we've got to work out is npq. Well, this is going to be equal to 100 multiplied by 5 over 6, the probability of failure. So this is 500 over 6. So to get sigma, we need to square root our result. I think it always helps to just pop in a very simple diagram, or just draw yourself a very simple diagram of the situation. Here we have the mean value. Here we have 95. This is the area that we want to calculate the probability of using the normal CD function on the calculator. So we've got a problem here with our 95 when we're working out the lower limit of the calculation we've got to make. The question tells us that Z enrolls a total of more than 95 sixes. So we want the area of 96 and above. Now 96 being a discrete column here will, if you consider bounds, occupy the space from 95.5 upwards. The curve now being continuous rather than a discrete value, 96. So the lower limit is going to be 95.5. The upper limit can be plus 999, way up here. The mean is 100, and sigma will be the square root of 500 over 6. So the probability of x being greater than 95.5, all these values into a calculator, and we get 0.689, and that is to 3dp. And that's the answer to part D.